So, I just wanted to cover a few last things so you guys could finish this packet tonight. We can get on to the normal homework in the book. The notation for inverse. As you know, notation is important in this class. So, if I have a function f of x, then the inverse is noted like this. And the way you read this is inverse f of x. Which is different than this, which we learned last year. So this f inverse of x does not equal 1 over f of x. It simply means the inverse. So if I wrote this function, then I would write the inverse is simply written like that. Inverse g of x. That's what that means. Okay. So if I wanted to find, given this function that we had up the page a little bit, if I wanted to find the inverse, I'm trying to find this, right? Okay. And the way that I'm going to do that is I'm going to solve for this x. Okay. So if I have f of x, right? Equals x plus 1 cubed minus 3. The first thing I'm going to do is add 3 to both sides. And I'm going to get f of x plus 3 equals x plus 1 cubed. Then I've got my next outermost function is dealing with this cube. So the opposite way, or the inverse operation of cubing something, is raising it to the 1/3 power. So I'm going to raise both sides to the 1/3 power. Okay, and my last step is to then subtract 1, and I would have f of x plus 3 to the 1/3 equals x. Now, so this is algebraically the way you would solve it. One last step would be to write the notation using the inverse notation. So I would say f inverse of x equals this thing, okay? And then I'm going to call that x. So that's x plus 3 to the 1/3 minus 1. Now, the one thing I don't like about the way the book does this is if this was Fahrenheit and Celsius, right, then these should stay Fahrenheit and Celsius. But the answers in the book will look like this, where they've actually switched the f and the x, and they switched those positions. But anyway, so here is the inverse of f, given that. Let's look on the next page. So let's look at all these things that we've done so far. So the graph of f of x equals, and let's look at them all in the same way. So the graph of f of x equals x squared minus 4. We know it goes through the point, 0 and negative 4, right? And then it goes through the points negative 1 and negative 3, 1 and negative 3, and 2 and 0, and negative 2 and 0. You can figure that out by either plugging them all in, right, and doing that, or recognizing the graph is shifted down 4 and then counting off. So here is the function f of x, except for it would actually go through all these points. Okay. So this is f of x, and this is f inverse of x. So all these points will be shifted. So negative 4, 0. So the function, the vertex, would switch to this point right here. 1, 2, 3, 4. And these points would switch to here and here. So this point would be negative 3, negative 1, negative 3, positive 1, 2, 0, and negative 2, 0. And then I can sketch my graph. Okay. Beautiful graphs there. Now, algebraically, we can say that, so if my original function is f of x equals x squared minus 4, right? First thing I'm going to do is add 4 to both sides and get f of x equal plus 4 equals x squared. Then the opposite of doing this is taking a square root. And so the square root of f of x plus 4 equals x. But remember, every time we take a square root, we have to take a positive and negative. And then the last step would be to flip the signs, or flip the variables. So f inverse of x equals the positive and negative square root of x plus 4. And you can see this is how we know that the inverse is a relation and not a function. Does this function have an inverse relation? Yes. Does it have an inverse function? No. Why? Because when you take a square root, you have to take into account positive and negative function. Okay. Looking at these graphs below, which have inverse functions? We can see that this first one passes the horizontal line test. There's no point where there are two x's for a given y. So this would, so yes, this one has a inverse function. No, this one does not. No, this one does not. This one I'm going to have to look kind of closely. And you can see if I draw a horizontal line, there's nowhere where any of these for any given y value that it intersects the function more than once. So yes. What determines whether or not it is would simply be for any y value, there is only one x. Okay. Now, those functions, a one-to-one function, when the inverse of a function is also a function, it is called a one-to-one function. So for example, this one, which is some form of x cubed, right? You can see that for every given y value, there's only one x value. So this is a one-to-one function. So when the inverse of a function is also a function, then it is a one-to-one function. This one is not, because you can see that there are multiple x's for the same y value, right? So this is not a one-to-one function, because the inverse is not a function. And let's check down here. So here's a table of values: 1, 3, 3, 5, 4, 6, 5, 1, 5, 6, 1. Okay. So for every x value, it is a function, because for every x value, there's only one y. But for every y value, these two y values have different x values. So this is not one-to-one. Or in other words, the inverse of c of x would not be a function, because for this given y value, I got different x values. Here, d of x is a function, because for every x, I get out the same y, okay? But for every y, I've got different x's. So this is not a one-to-one. And finally here, you can see that the e of x is a function. I put in a 1, put in a 3. Every time I put in the number, I get the same thing. And then for every y value, I get a unique x value. There's only one x for each y value. So this would be a one-to-one function. So now lastly, I want you to think about this. Social Security to height, right? If I put in a Social Security number and get out a height, that will be a function. But if I put in 510, are there more than one Social Security number with the same, or more than the number of people? If I put in height, right, am I going to get out more than one Social Security number? Well, I bet even in our class there are some people that are my same height or close, if we round it off to inches, that have different Social Security number, right? So it would not be a function. The inverse is not a function, so it is not one-to-one. Now, if I plug in driver's license number and I get out specific person, right? If we switch that around, so my inverse of that, if this is, we'll call this g of x, right? So my inverse would be switching x and y, specific person, and driver's license number. For every specific person, so let's say Talia, right? If her driver's license number is going to match up with her every single time. Or if I put in Connor, right? He's going to get the same driver's license number. So that would be a one-to-one. Okay, and ideally no one has two driver's license numbers. Anyway, thanks for watching the video and filling this out. Just take the rest of tonight to make sure that you understand these two packets. Bring your book tomorrow.